Hello students, this is the second video of the playlist where we are learning about surds and we will learn about simplification of surds today. We will try to simplify surds. Now when you have surds given like this, we have to simplify them. Now simplifying them means that we have to write surds in the simplest form. Write surds in the simplest form means that when you have surds of this form, let's say you have 2 root 3, then the surd we have here has a prime number inside the root. So when you have a prime number inside the root, that surd is the simplified surd for us. So in these cases, what we do is we go for the prime factorization. We all know what prime factorization is. Prime factorization is trying to write out this number, whatever we have here, this number as a product of prime numbers. So we have 243 in here. Now we have all done prime factorization previously. We know 243 because the last number is 3. So it can be divided by 3. So 243 can be divided by 3 and we get 81 in here. Now we know that 81 again can be divided by 3. So we get 81 divided by 3, which is 27 in here. And we now know that 27 is again divided by 3, which gives us 9. So 9 divided by 3 gives us 3. Now 3 is a prime number. We know we cannot divide any further. So we stop here. Now how many 3's do we have here? We have 1, 2, 3, 4, 5. 5 3's make up 243. So we write 243 as 3 into 3 into 3 into 3 into 3. So we have 1, 2, 3, 4, 5. So we have 5 3's here. And now we know that we have seen where we learned about the rules that if you have root a into root a, then you can write it as a. Or simply when you have root a square, you can write this as a because the square and the root gets cancelled out, right? So here we are going to do the same thing. We are going to find out the pairs that make up the squares. So we have 3 and 3. So we can write this as root over. These two 3's make up 1 3 square. And then these two 3's, these two make up a pair. These two make up a pair. So we have 3 square and this 3 is here alone because we do not have anything to form a pair with. So 3 square, we know that we can write this as 3 square into root over 3 square into 3. So now each of the squares and the root will get cancelled out. So square and root gets cancelled out. Square and root gets cancelled out. We'll have a root 3 in here. So we get 3 into root 3, which can be written as 3 3's are 9 root over 3. So 243 can be simplified and written as 9 root over 3. Now, instead of doing all of these steps, we can follow a shortcut. Now, the shortcut is as follows, that for every two same number, when you have two same numbers, one number will come out of the root. You can keep it in your mind like this. And instead of following these two steps, you can directly jump from this step to this step. See, you have 2 3's in here. So out of these 2 3, 1 3 will come outside. You have that here. Out of these 2 3, 1 3 will come outside. And we have this 3 in here. And then this 3 is alone. So it will stay inside the root. And 3 into 3 gives us 9. And then we have root 3. So 9 root 3 is our answer to this simplification. The first method, the method with all of these 1, 2, 3, 4, 5 steps, is the detailed method. And the next one, which I showed you, the one where we jump from the first to this step, is a shortcut, which is definitely an allowed one. So you can follow this one as well. It's easier to remember, and hence there are less chances of making any mistakes. So with this, you are asked to simplify this one. Now, in this second one, you see that the sum that we did just now, it contains 3 of those kinds of surds in here. These are definitely not simplified surds, so we need to simplify each of them. So for 28, you know the last number that you have here is 8. So definitely this number will be divided by 2. So when you divide it by 2, you get 40. So when you divide it by 2, you get 40. So divide 14 has a 4 in the end. So we know that it can be divided by 2. So we have 7 in here. Now 7 is a prime number. So we stop. Now for 175. So for 175, we know we have a 5 in the end. So whenever we have a 5 in the end, that number always gets divided by a 5. So 175 divided by 5 will give you 35. And we know 35 is 5 sevens are 35. So we have simplified this one as well. We know the prime numbers that make up 175, and the last one is 112. So when we write 112, we know 112 has a 2 in the end, so that will be divided by 2 and we get 56. So when we divide it by 2, we get 56. Now 56 has a 6 in the end, so if you want, you can divide it by 2, and if you want, you can also divide it by 3. It depends on you. So I chose 2 and I got 28 in here. So we have an 8 in here, so we know that it will again be divided by 2, and it follows somewhat the same steps as this one. So we will have 14, and then we will have 2, and we will get 7 in here. 7 again is a prime number, so we will stop our calculations. Now for 28, what did we see in here? We got 28 by multiplication of 2, 2, and 7. So we will write that in here. We know 28 is a product of 2 and 2 and 7. 2 2s and 1 7. Then 175. 175 can be written as a product of 5, 5, and 7. So we will get what? We will write it as 5 into 5 into 7. Now for 112. So for 112, we have 2 into 2 into 2 into 2 into 7. So we have 4 2's multiplied. 1, 2, 3, 4. 4 2's multiplied with 1, 7. So it gives us 112. So we have 4 2's. So 1, 2, 3, 4 2's and multiplied with a 7. So now from the shortcut that we have learned, we know that for every 2 number, 1 number will come outside of the root. So we have 2 2's in here, right? 1, 2, 2 2's. So for every 1 pair of number, that number will come outside, and then 7 stays inside the root. Now we have 5 into 5. So we know for every 2 5, 1 5 will come outside, and then there is nothing to pair with 7. So 7 stays inside the root. Now for this one, for these 2 2's, 1 2 will come outside. For these 2 2's, 1 2 will come outside, and then we have a root of 7 in here. So we have 2 root over 7 minus 5 root over 7 plus 4 root over 7. Now we know that it's more like you have 2 pence minus 5 pence and then plus 4 pence. So we know that we can easily do the calculation as such. So 2 roots over 7 minus 5 root over 7 means you have minus 3 root 7 plus 4 root 7, which gives us only root 7. So 2 minus 5 plus 4 gives us 1 root 7, and we do not write the value of 1 in front of any number that we multiply 1 with. So we have written only root 7 in here. Now let's do a quick recap of what we did here. We have different numbers. We have root 28, root 120, root 175, and root over 112. We know that for different roots, when we have different type of roots, we cannot add or subtract them. We have seen in the previous video that we only add or subtract roots of the same type. Here, all of the numbers are different, so the roots are of the different types. They are not of the same type. So for doing the calculation, what we did was we simplified each of the roots first. In order to simplify the roots, we have seen in the previous example that we have to take prime factorization. Our root is said to be a simplified one when we have a prime number inside the root. So we tried to simplify them. We tried to write all of the numbers that we have in here, 28, 175, and 112, 28, 175, and 112 as product of prime numbers. Product means multiplication. Multiplication of prime numbers. So we have written them here. We have written all of the numbers in here. Now we know that we will apply the shortcut in here. What is the shortcut? The shortcut is for every two same numbers, one number will come out of the root. So for every two same number, one number has come out of the root, as we can see from here. See, for every two numbers, 2 and 2, 1, 2 has come outside of the root. For every two number, 5 and 5, 1, 5 has come out of the root. For every two same numbers, this 2 has come in here, this 2 has come in here. So now we know from the rule of BODMAS that we have to multiply first. So 2 and 2 gets multiplied first, and we have 4 in here. Now we will just add them because we have a minus in here, so we need to subtract this 5, and we have a plus in here, so we will add this 4, and we get our answer by simple addition and subtraction. Are we clear? Then let's move to the next one. Here we have multiplication in between the numbers. So we know that when we have multiplication, it becomes easier for us. Why? Because we know that we can multiply and divide different kinds of roots. When you have separate type of roots, which is very evident in here, we have root 5, root 125, and root 8. All of these are different. So when we have roots of this type, what do? We can simply multiply them. If we want, we can write this as root over 5 into 125 into 8, right? We know that this is possible, but the problem arises when you follow this step immediately is that by instincts we will multiply all of these numbers. We will multiply 5 with 125 and 8, and then we will write here root over 5,000 like this. Now, in order to simplify, we know that we have to write this one as a product of prime numbers and then simplify it, right? But when we write this as a product of prime numbers, 5,000 is a very big number for us. To write it as a product of prime numbers, 5,000 is a very big number for us. It becomes a very difficult job. Not a very difficult job, but a very lengthy one, I would say. So instead of following this step, instead of going for this step, we follow the next line. What is that next line? The next one is we try to simplify these surds first. Instead of multiplying and then simplifying, there are two methods of doing it. The first one is you multiply first and then simplify. This one, becomes a lengthy step because this 5,000 is a difficult task for us to deal with. What we are going to follow instead is we will simplify the roots first. Simplify first, then go for multiplication. How is this an easy one? Let's see. Because we have root 5 in here, we know root 5 is the simplified root, right? Because 5 is already a prime number that we have in here. Then comes 125. Now, if we try to find out the prime factorization of 125, we have 5 in the end. So we know it will definitely be divided by 5. And we get 25 in here. So now we know 25 can also be divided by 5 and we get 5. So 125 can be written as product of 3 5s. So we write 125 as root over 5 into 5 into 5. And the next one is root 8. Now let's try to find out the factors that make up root 8. So for 8, we know it will definitely be divided by 2. So we get 4 in here, and then dividing by 2, we get that 8 is a product of 3 2s. So into root over 2 into 2 into 2. Now for simplification, we know that for every two numbers, one number will come outside. So there is nothing to simplify in here. For the next one, we have 3 5s. So make a pair with any 2 5. For these two, we make a pair with any 2 2s. And so we will get root 5 into 1 5 will come outside of the pair and 1 will stay inside the root. And for here, 1 2 will come outside and 1 2 stays inside. So now we have 5 into 2. We multiply just like algebra. If you get confused with the rules of surds, think the surds as different algebraic variables. So root 5, let's say this same thing, imagine it as x, and then this one is 5x, and then this one is 2y. So you know x and y gets multiplied and the numbers in front of them get multiplied. So we will follow the same process in this. So what we will do is we will multiply the numbers outside the roots and multiply the numbers inside the roots. So the numbers outside the roots are 5 and 2. So 5 and 2 will get multiplied. So 5 and 2 will get multiplied, which are outside the root. And then we will multiply the numbers inside the root. So inside the root, we have 5, this 5, and then this 2. So we will have 5 into 2, 10 outside the root. And now for inside the root, do we multiply first or we take out the 5 outside? By now, if you're paying attention, you will understand that we have to take this 5 outside for these two 2's, right? So instead of taking the root, we will first take the 5 out and then we will write 2 in here. So we get 5 into 2, which is, 5 into 10, which is 50, and then root 2. So a quick recap of whatever we did here. So the numbers are different. All the roots are different, but we know that for in case of multiplication and division, for multiplication and division, we do not need to concern ourselves with the fact that whether the roots are same or different, because for multiplication and division, we can multiply and divide the same or different kinds of roots both. So there are two approaches that we can take here. The first one is we multiply and then simplify. This is the first kind, that we multiply all of the roots and then simplify. What is the other kind? The other type is you simplify first, because you see 125 here is not a simplified root. 8 here is not a simplified root. So we can simplify first and then multiply. So root 5 here is simplified. 125 is simplified as such. And root 8 is written in this manner. For this, we have found out the prime factorization first and then simplified. Now, the problem with the first one was that if we multiply first, we get a very big number. It is difficult for us to factorize a very big number because sometimes here there were zeros, an easy task for us, but not always we will get zeros in here. So in that case, trying to find out factors that you can divide with is not very easy, especially when the prime number is not an easy one as 5 or 2, and we get numbers like 23 or 17. Then in those cases, it becomes a difficult task for us. So we try to avoid this method and we use the second one. So in the second one, we have simplified the factorized the numbers first and then simplified. And then what we are doing here is we are multiplying these two numbers that we see here, the numbers outside the root, and we are multiplying the numbers inside the root. We multiply the numbers outside the root and the numbers inside the root separately. So we have 5 and 2 in here, we multiply them, and then the numbers inside the root, which were 5, 5 and 2, we multiplied them inside the root. Now, before we simplify in the next step, or we multiply these numbers in the next step, we see that inside the root we have two same numbers. We have got two same numbers inside the root. So getting two same numbers inside the root means that one number can come outside, which we have done in here. We have taken this 5 outside and then 2 stays inside the root. So 5 into 10, then we get 50 and a root of 2. With this, let's move to the next sum, which is looking something like this. Now for this one, see we have 3 minus root 2 whole square. Now this one resembles the formula in algebra which we have learned as a minus b whole square in our early days. We know that this formula gets equal to a square minus 2ab plus b square. So we are going to apply a similar concept in here. So in here, our value of a is 3 and value of b is root over 2. So a square, which means we have 3 square minus 2, a is 3, b is root over 2, and then we have plus b square, which means we have root over 2 squared. So we get 3 squared is 9 minus 2 3s are 6, and this is a number inside the root, so we cannot multiply it. We cannot multiply the numbers inside the root with the numbers outside the root. These two will be handled in separate calculations. 2 was a number outside the root, 3 was a number outside the root, so we could multiply them. These are numbers outside the root, so multiplication is all right in here. But these two numbers cannot be multiplied with the 2 inside the root. The reason for that is 2 is a number which is inside the root and these two numbers are outside the root. We cannot mix them up. And then we have plus. Now, root and square. We know that the square and the root are opposite operations, so they can cancel each other out. And we will get only 2 in here. So now when we add up 9 plus 2, we know that addition and multiplication, addition and all the other operations that we have, they depend on the sign before the number. So in here, you are subtracting the 6 root 2 and you will be adding 9 with root 2. We know that 6 root 2 has a root with it. So it's a surd and it cannot be added up with any other number. So 9 plus 2, this is 11 and then minus 6 root over 2 is your final answer. You cannot add or subtract different types of roots. We know that here the root was root 2, and then with 9 and 2 we did not have any other roots, so we did not add 9 or 2, either of them, with 6 root 2. In this example, we have 3 plus 2 root 3 whole square. 3 plus 2 root 3 whole square is similar to the example that we did of a plus b whole square in class 7 or in earlier years. So a square, we know the formula is a square plus 2ab plus b square. So we apply that same formula in this one. Here the value of a is 3. We have a plus in here, and the value of b is 2 root 3 as a whole. So we have a square plus 2ab plus b square. So we have a square, which is 3 square. So 3 square is 9 plus. We know that we multiply the numbers outside the root. So outside the root, the numbers are 2, 3, and these 2. So all of these will be multiplied. So we will get 2 3s are 6, 6 2s are 12. So we will have 12 root over 3 and then plus. Now we have a square. This square is over the entire bracket. So it means that this square is over both 2 and root 3. It's over both. So we have a square over 2 and we have a square over root 3. Both of these. So we are going to get 9 plus 12 root 3. Nothing to simplify in here. And then 2 square. 2 square is what? 4, we know. And then we know also that square and roots are opposite operations. So these two will get cancelled out. And with this 4, we are left to multiply these 3. So we have 9 plus 12 root 3 plus 3 4s are 12. So what are the numbers? 9 and 12 are the numbers. This 12 root 3 is the surd. So we add up the numbers. So 9 plus 12 is going to give us, from our calculators, 21. And then from here we will have 12 root over 3. If we take a look at the next example, we have a situation like this. Now this is a case of an example like this, where we had 3x plus y and then 2a plus b. We have all multiplied this one. We know how the multiplication works, right? We multiply 3x with 2a plus b in algebra, and then y with 2a plus b again. And then this 3x gets multiplied with 2a, then this 3x again gets multiplied with b. This y gets multiplied with 2a, then with b. We will apply the same process in this one. It's more like algebra. The last 3 sums that we have seen, this one and the previous 2, they all resemble some formulas in algebra. So how do we do this one? We know that 2 will first get multiplied with root 2 plus 3. And then we know that this root 3 will get multiplied with root 2 plus 3. So if we multiply, we have 2 into root 2. Now this 2 is outside the root, this 2 is inside the root. So we cannot multiply them together, and we will keep it as it is. Then 2 and 3 both are numbers. So 2 into 3 gives us 6, then plus. This root 3 and root 2, These are both numbers inside the root, and they are being what? They are being multiplied. I know that I can multiply these numbers because for division and multiplication, the different types of roots or same type of roots, they do not matter. So we have root over 3 into 2. And then again for root 3 into 3. This root 3 is the number inside the root. This 3 is the number outside. So we cannot multiply them. And we keep it as it is. Now, we have 2 root 2 plus 6 plus 2 3s are 6, which gives us root over 6 plus 3 root over 3. Now, root over 2, root over 6, root over 3. All of these are different types of roots. They are not the same type. Again, root 2 and root 3 are both prime numbers, so they cannot be simplified any further. Root 6 is not a prime number, but then again, we cannot simplify root 6 either, because we have just seen that root 6 is a product of root 3 and root 2. 3 and 2, two different numbers. None of the number comes outside for being the same number, so we cannot simplify root 6 further. So we will keep it as it is. Now, because all of these three roots are the same type of roots, we will keep them as it is. And then we have a 6 to add with it. 6 is a number, not a root. So this is our final answer. And with this, we learned the second criteria for simplification, which is that if we have a number inside the root, which is also not a prime number, but it cannot be simplified any further, so we leave it up to that. In the first example that we saw, or we tried, we said that whenever we are asked to simplify, our objective is to get a prime number inside the root. If we get a prime number inside the root, we know prime numbers cannot be dissociated any further. They cannot be written into any simpler terms. So it is the most simplified form. But then again, if we have numbers, let's say numbers like 15 inside the root, we know 15 can be written as root over 3 into 5, right? So 15 can be written as 3 into 5. Now 3 and 5, none of the numbers can come outside. So 15 in this case is a simplified root. Now let's get back to where we were studying. This one is the last example that we have for today, which is 2 root 3 minus 3 root 2. And then we have 2 root 3 plus 3 root 2. So if you focus, you see that the first numbers here, 2 root 3, 2 root 3 are same. And then we have 3 root 2 and 3 root 2. The numbers are same, but they are separated by two different operators. One of them is plus and one of them is minus. But we have seen in algebra that we do have a formula of this type. A plus b into a minus b, which gives us a square minus b square. If you want, you can follow the methods of expansion, just like how we did in the last sum. This expansion technique, which we followed in here, is the same technique can be applied to this one. If you want, you can follow that technique. You can write 2 root 3 multiplied with this whole bracket, then 3 root 2 multiplied with this whole bracket. And then when you simplify, you are going to get the same answer ultimately. And this same technique can be followed in the previous two sums. You know that if you have x squared, it means x into x. If you have a squared, it means a into a. So if you have 3 plus 2 root 3 square, then it means it is 3 plus 2 root 3 multiplied with 3 plus 2 root 3. So again, you can multiply 3 with these two, then 2 root 3 with these two. It follows the same techniques of expansion. You are going to get the same answer. So in this one, if we use the shortcut or the expansion technique, whichever method you prefer, you are going to get 2 root 3 square minus 3 root over 2 square. Now, square over the bracket means that the square is over both 2 and root 3. So we have 2 square and root 3 square, and then minus for this one, again in the same fashion, we have 3 square and root 2 square. So we have 2 square 4 into, we know that the square and the root gets cancelled out, leaving us with 3 alone. So 4 and 3 gets multiplied, then minus 3 square gives us 9 into, this square and root again will get cancelled out because they are opposite operations. So we will write only 2 in here. So we get 3 fours are 12. We know from the rule of BODMAS, we first multiply and then we subtract. So, or simply the very first thing in BODMAS or BIDMAS, whatever you have learned, is B. So you need to take care of the bracket first. So 9 into 2 gives us 2 9s are 18. So 12 minus 18 will be your answer for this one, which gives us minus 6. Now, the very good thing about Surds is that whatever sum you do, you can definitely check them up from your calculators. You put this entire thing in the calculator, whatever is given in the question, you put this in the calculator and the calculator will give you this final answer. So it is a good thing in exams because it helps you check the answers. So you can always practice this in at home and then review your answers so that you do not make any mistakes or lose any marks. With this, we are done with the simplification. In the next videos, we will be trying out the second part, which is the rationalization of surds. That's all for today.